Hello, I'm Dr. X. Today we'll explore an exciting area of medical research, how vitamin D3 supplementation, specifically at a dose of 2000 international units per day, may promote longevity by preserving telomere length. Telomeres are protective caps at the ends of our chromosomes, and their gradual shortening is a hallmark of cellular aging. Recent randomized controlled trials, including sub-studies of the VITAL trial, suggest that vitamin D3 may slow this shortening process, offering a potential strategy to extend cellular health and reduce age-related disease risk. Over the next 15 minutes, I'll explain what telomeres are, how vitamin D3 interacts with them, the mechanisms involved, and what this means for clinical practice and everyday health. Telomeres are repetitive DNA sequences located at the ends of chromosomes. They function like the plastic tips on shoelaces, preventing DNA from fraying or fusing with other chromosomes. Each time a cell divides, telomeres shorten slightly. When they reach a critically short length, cells enter senescence or programmed cell death. This contributes to tissue aging and is linked to cardiovascular disease, diabetes, cancer, and neurodegenerative disorders. Telomere length is now considered a biomarker of biological age. Longer telomeres are associated with healthier aging, while shorter telomeres correlate with higher disease risk. Preserving telomere length is therefore a promising pathway to promote longevity. Vitamin D3, or cholecalciferol, is traditionally known for bone health and calcium regulation. But vitamin D receptors are present in nearly every tissue, suggesting systemic effects. Observational studies have shown that individuals with higher vitamin D levels tend to have longer telomeres. More importantly, randomized controlled trials provide stronger evidence. In one study, over 1,000 participants were followed for 5 years. Half received 2,000 IU of vitamin D3 daily, while the other half received placebo. Those supplementing with vitamin D3 demonstrated slower telomere shortening compared to controls. The VITAL trial, involving nearly 26,000 participants, also found that vitamin D supplementation helped preserve telomere length in white blood cells. This dose, 2000 IU daily, is above the minimal recommended allowance but well within the safe range for long-term use. It appears to provide sufficient systemic levels to exert anti-inflammatory and antioxidant effects, which are key to telomere preservation. These findings suggest vitamin D3 may act as a modulator of cellular aging, reducing the risk of age-related decline. How does vitamin D3 help preserve telomeres? Several mechanisms are proposed. First, anti-inflammatory effects. Chronic inflammation accelerates telomere shortening. Vitamin D3 reduces pro-inflammatory cytokines such as IL-6 and TNF-alpha. Second, oxidative stress reduction. Telomeres are highly sensitive to oxidative damage. Vitamin D3 enhances antioxidant defenses, reducing reactive oxygen species. Third, immune modulation. Vitamin D3 influences T-cell differentiation and macrophage activity, promoting genomic stability. Fourth, epigenetic regulation. Emerging evidence suggests vitamin D3 may influence gene expression related to telomere maintenance. These mechanisms collectively support the hypothesis that vitamin D3 acts as a cellular protector, slowing the biological clock at the chromosomal level. These findings are promising, but telomere length is only one aspect of aging. Lifestyle factors, diet, exercise, sleep, and stress, also play critical roles. Vitamin D3 supplementation should be individualized. While 2000 IU daily is generally safe, excessive intake can lead to toxicity, including hypercalcemia, kidney stones, and vascular calcification. Patients should consult their healthcare provider before beginning supplementation, and serum 25-hydroxyvitamin D levels should be monitored. In clinical practice, vitamin D3 may serve as a low-risk adjunct to other longevity strategies. It is not a panacea, but it is a compelling tool in preventive medicine. In summary, daily supplementation with 2000 IU of vitamin D3 may help preserve telomere length, offering a potential pathway to healthier aging. This adds to the growing body of evidence that vitamin D3 supports not just bone health, but systemic cellular resilience. As clinicians, we must stay informed about emerging research and guide our patients with evidence-based recommendations. Healthy aging is multifactorial, but vitamin D3 may prove to be a valuable ally in this journey. Thank you for joining me today. I'm Dr. X, and I look forward to continuing this exploration into the biology of aging and the tools we can use to live longer, healthier lives.